This morning we're going to go through some of the pieces and parts of the new N Merlin bottling machine. This is to familiarize you with the different parts, how it's connected, how everything works, and where things go. I hope that this will help everybody to understand more about how to hook up these machines and operate them. So we'll start with the pieces and connections first. On the very top of the machine is the fill manifold. It is the round tube with the stainless steel bar to the left. This stainless steel tube connects directly to a 1-inch hose that goes to your bright tank and connects directly to the manifold. On the right hand side of the manifold is a small fitting that is used to detect pressure in the control panel. This clear tube goes down into the control panel right hand sensor and tells the computer at all times what pressure the filling product is at. The stainless steel bar here in the middle is our pinch valve. It moves in and out to start and stop the flow of product by pinching these silicone hoses, which are in turn connected to stainless steel filling straws. The connection between the silicone hoses and the stainless steel filling straws is straight through. In the center of our filling block are two T's. The top T is connected to the off-gas tubes, which are these with the slots in them. The bottom T is connected to what we call the sniffed tube, which is up behind the rubber washer that seals against the bottle itself. Connected to these two tubes on the upper left-hand side facing the infeed of the machine are two CO2 control valves. The one on the right is the pulse valve and is physically connected to the off-gas tubes. This valve is used to create a pulse of CO2 and create foaming, which we'll talk about later in the video. On the far right in this portion you see a blue tube, translucent, coming up out of the top there. This is the bottle side sensor line which goes into the control panel. We'll talk about that later as well. The CO2 valve in the middle of the picture here is connected to the sniffed tube area and is used to counter pressure the bottles and inject CO2 after pre-evacuation. The hose barb here is connected directly to your CO2 source and set at 35 pounds per square inch to provide CO2 counter pressure and purging to the machine. On the other side of the two T's that come from the middle of the filling block, they come down and go to our off-gas assembly area. Down here, below the machine, below the control panel, the black knob is called the speed valve. This is your manual control for how fast product is poured into the bottle. The one to the left that does not have any sort of adjustments and the orange tube connected to it is the sniffed valve. The sniffed valve contains a ported orifice and controls the rate that gas comes off the bottles after they're filled. The center valve here with the black hose on it is called the block valve. There's one on each side, on both the speed side and the sniff side. These are used to shut off all gas flow so that the bottles can be counter pressured. The long plastic piece here with the black hose on it is called an adductor. It is the device that creates the vacuum for evacuating the bottles. Again, there are two of these, and all these components are shown in your parts list inside the manual. Looking at the machine from this side, up on the beer manifold or product manifold at the top, there is a small brass fitting with an orange collar. This is where your temperature probe plugs into to read the actual product pressure going into the bottles. It does not go through, it merely touches the stainless steel tube and gives us an accurate reading of the product temperature. This is to aid you with making adjustments during the filling process. As we step back a little bit further, again our CO2 connection is here. And here we see a line of 6 cylinders on top of the crowning bar. The 6 cylinders are called ejection cylinders because they push the bottles back out after crowning. Again, we'll talk about this a little bit later. This valve is for the after crowning rinser. You will need to connect some sort of a fitting for a garden hose or whatever type of connection you need for your rinse water. It is physically connected to a bar under the cap slides with 2 sprayers that'll rinse the bottles off as they go through the machine. This is only activated while bottles are moving. Attached to the crowning bar is the bottle locator. The bottle locator is the nylon piece with holes in it that the filling straws go through, and it also locates the bottles underneath the capper and holds the crowns in place when the capper comes down to correctly crown the bottles. The acrylic bar here, if your machine is equipped with one, is called a bottle separator. And its job is simply to separate the bottles from each other as they come down the sloped ramp so that there's clearance. This will help if you have pre-labeled bottles or silkscreen bottles because it'll keep them from sticking together. Looking at this block on the back of the filling head, these cylinders are rodless cylinders and they're used to move the filling block up and down. They're magnetically coupled and require no service, but they should be kept clean at all times. The plate here that the main frame is mounted to and bolts down to this large cylinder, which is the capping cylinder, it does all the work of pulling down the crowner bar to put caps onto the bottles. Crown sorter. The crown sorter consists of a hopper here on top where you put your crowns. There is a rotating shaft that goes all the way through the unit with magnet hubs on it that pick up the caps from the hopper, and then they must go through the primary excluder, which is shaped such that the crowns can only go through in the proper direction. As they move around the drum, they come to the crown slides. The paper clipped plastic secondary excluder here is used to ensure that the crowns always go into the slides in the proper orientation. The catch tray is used for those crowns that flip in the wrong direction between the primary and secondary crown excluders, or when the slides get completely full, sometimes it can drop caps. It simply catches the caps in a clean tray so that you can put them back in the hopper and reuse them. To actuate the back and forth movement of the crown sorter, there's 4 pneumatic pistons here that operate a rack and pinion. This is what causes the cap sorter to rotate 450 degrees into the hopper and then 450 degrees into put the caps in the slides. N-series machines are also equipped with a bottle detection feature that is actually a pneumatic device. Shown here, it blows a small jet of air out, and when bottles are properly located under the filling station, detects their presence. This is used so that we can tell if the bottles have properly fed through the machine and even if the row did not advance. Bottle movement through the machine is done with an indexing plate. The indexing plate indexes forward from underneath a sloped ramp and is adjustable with slotted holes and fastening bolts on both sides of the support. There's also speed controls on the bottle indexing, which are these thumb knobs on both ends of the cylinder. The one on the back of the cylinder controls the retracting speed. The one underneath the machine controls the forward speed. This is very important because we need the bottles to index slowly and smoothly forward to get underneath the capping station about a half a second before it comes down. The plate can retract a little bit faster, which helps to ensure that the bottles fall properly. Also, underneath the machine are quick exhausts. These quick exhausts are used on the capping cylinders to get the air out fast and keep them moving quickly. This also helps with keeping the force of capping sufficient so that the crowning cylinders on their way down do not hesitate. Crown feeding to the machine is done through these slides, crown slides. They're stainless steel U-shaped slides that the crown slides down, and there is an escapement, a set of pins mounted to the bar here, and there's 2 pins per slide. The bottom pin is always extended, and when crowns are needed to be dropped into the capping head, the bottom pin retracts at the same time the top pin extends and holds the pile of caps up. In this way we drop one crown at a time to the crowner just before it starts down. When the crowns come down, they come to the bottle locator. They land on this stainless steel strip as they come out of the chutes, and they bounce into the bottle locator ready to be crowned on the bottles. Here is a bottle locator removed from a machine. This shows the stainless steel strip that the caps land on, and also the 3 magnets that support the cap. As it comes down and hits the stainless steel strip, the magnets pull the cap into location and they suspend it in air. The bottle ejection cylinders, which I talked about earlier, also have a plunger on them that locate the top of the crown. So when the crowner comes down, it locates bottles exactly underneath the capping head and underneath the filling station. This is a bottom side view of the bottle locator. You can see that we have very deep pockets tapered for the filling station and a small lead in on the crowning section at the top of the screen. Bottling machines are powered by pneumatics, so it requires a good air supply, which is connected to the regulator on the bottling machine located on the frame. Near the regulator, you'll find the serial number of the machine stamped into the frame. The serial number identifies how many heads the machine has, its series by letter, its ounces, or the size of the bottle that it is made for, followed by 3 letters which designate the mold number of the bottle that the machine is made for, and finally the last 6 digits are the in-service date of the machine. Compressed air is essential for the bottling machine, and it needs plenty of it. So you will need a compressor with a minimum of at least 15 cubic feet a minute at 90 psi for a volume rating, and a minimum turn-on pressure of at least 100, so that the machine is never starved for compressed air. On the regulator here shown, we preset the regulator at the factory at 95 psi in the static condition. While the machine is operating, you should never see this gauge drop below 80 psi. If it does drop below 80 psi, you may start to see problems with crowning, loud noises during the crowning, indexing issues, and other timing issues which are associated to an air shortage. If this happens, you need to ensure that there are no commodities between the air compressor tank and the bottling machine, i.e. no extra regulators, filters, dryers of any kind. The hose size must be at least 3/8 of an inch inside diameter for a 50-foot run and shorter, and no restrictive fittings such as quick couplers that are not the ones that we supplied with the bottling machine. Now we move on to the control panel. The first screen on the control panel shows the wizard, who the machine was made for, and in the bottom right hand corner has the programs for both the HMI screen and the computer, as well as the series of the machine. On the right hand side of the panel is a control valve. This is called the liquid pressure control valve, and it can be used to put the pressure on top of your bright tank to dispense the beer to the filler. This is a very accurate way of doing it and will maintain a constant pressure at all times, enhancing your filling experience with the machine. If we open the door and take a look inside, this is the back of the HMI panel and the power switch that turns the machine on and off. Inside, to the far left, there is an INOR transmitter. This is the transmitter that brings in the temperature signal from the manifold outside on top of the machine. Green cable is communication between the computer and the interface. This computer card here with the blue and white wires is called the analog card. Down in the lower left hand corner are a couple of very sensitive switches. These are connected to the bottle detection devices that I showed you earlier. These give an input signal to the computer that tells it that bottles are present. And because there is a signature of timing of on and off for these bottles, we can tell that bottles are properly located and that they have indexed correctly into the machine. This is only available on N-series machines. Across the bottom of the panel are 10 valves. 9 of them are of a smaller size. The one on the far right is larger and operates the crowner. Each one of these valves has got an indicating light on its front, which you can use during manual override and testing of the bottling machine, which we'll go through later. On the far right, the 2 sensors. The one on the right with the clear line goes all the way up on top and connects to the manifold that we talked about earlier, which gives us the beverage pressure at all times. The one on the left is connected to the translucent blue line, which went all the way over by the CO2 connection that gives us the bottle pressure at all times. Looking at the bottom of the panel, all the colored tubing comes into the bottom and connects to each one of the control valves up above. Each one of these hoses is labeled with its position in the manifold and whether it's an A or a B line. The B lines are all in the back, the A lines are all in the front, and it should be noted that in the normal condition without the valves actuated, the B side always has compressed air on it. Briefly, here is the bottle rinse rack. It consists of rods that run through the bottom of it. Each rod has got small orifices drilled into it and is connected by a fitting underneath the machine. The smaller fitting to the right is where you connect your pump or liquid supply, which connects to all those bars we just looked at. The tube to the left, the larger one, is a 3/4 inch, and it's a drain back tube. It just simply drains out the liquid or sterile water solution that you're using for rinsing. On the back here, the blue and black switch goes inside the panel, back panel of the rinser, right here, and when the bottle handling plate pushes that switch, it turns on the piggyback cord connected to either your pump or a solenoid valve for the rinse solution. Bottle handling plates have 2 halves. The bottom half has got round holes in it with a taper leading in for the bottle. These 2 plates are spring loaded so that you can squeeze them like this to get the bottles. On the other side, the top plate is a matching keyhole. The keyhole is what actually grabs the bottles by the handling lip. To load bottles, squeeze the plate. That brings a round hole over the large part of the keyhole, place it over the bottles, and then release. Here is a demonstration of the operation of the plate. Place it over the bottles, squeeze the handle, let the plate slide back so that the keyholes can grab the handling lip on the bottles, and then you've got them so that you can pick them up and put them in the rinser. Once the bottles are in the handling plates and in the rinser, the plate slides back and hits the switch. This is the rinse position, and you just let it rinse for a few seconds, and then just simply pull the plate back a little bit, allow the bottles to drain. When you want to put bottles on the machine, you flip the plate over, set them on the sloped ramp of the filler, and the bottles feed down by gravity. I will now go through the screens for the bottling machine, the controls, and what they all do. The initial screen, of course, is the wizard with the information about the bottling machine on it. Simply touch the wizard, and that brings you to this screen. Auto filling, auto clean, auto sanitize, and the manual override screens. We'll start off with the manual override screens. This is used for troubleshooting and testing all of the components on the machine. On this screen, you can see that there are controls and numbers for each and every one of the functions of the bottling machine. For example, speed valve is 0. You press it and it actuates that particular component so that you can test it. The button also turns green while it's depressed, so you can test every one of the functions of the machine. CO2 valve, cap drop, bottle index, fill heads, fill valve, eductors, crowner, and tank control valve, the CO2 pressure. The bottom left portion of the screen is a counter. These counters, rows times 10,000 filled, rows of bottles filled successfully, only records bottles that have been properly filled and a fill detection established. It does not count bottles that have been rinsed, sanitized, or unsuccessful fills. This way you can pretty much keep track of what you need to do, of the bottles that you have filled. Keep a count. This machine also has the pressure sensor readings on the right hand side of the screen, and it has a auto leak test function, which is another screen which tells you exactly what it's going to do. Bottle pressure is displayed on the right hand side. So at this point I have no bottles on the machine. It's obviously going to fail, but if we start the process, the program is failed. It should also be mentioned at this time that the leak test is the only program that we do that you do not reset before starting. So rather than hit reset, you go straight to leak test and it starts to run. Everything moves, indexes bottles, and it fails because we had no bottles in place. We did not read any pressure on this side. If I had pressed reset before starting the leak test, it would not have run. Okay, now we're going to try the test again with bottles present and CO2 pressure connected to the machine. Bottles index forward, the regulator opens. The blue bar indicates that pressure is made. It is normal for the blue bar to start down just a little bit initially, and then it will stabilize very quickly and hold pressure. The test runs for approximately 1.5 minutes, and at any time during the process, if a leak is detected, it will stop, flash the light, give you the message that leaks were detected. The best way to find leaks is to keep running this process because it pressurizes the entire system, and if it's a very small leak, it can aid in spraying soapy water around the connections, the male connectors on the fill straws, bottle seals, any part of the system that is a possible leak. Leaks can cause counterpressure fail, which is the most common issue, especially if something is broken, like a male connector that holds a filling straw. Okay, now I'm going to demonstrate how to test the speed and sniff valves as well as the adductors and block valves on the machine. These are the valves down here. If you'll recall, the speed valve, this one, is connected to the top T on the fill manifold, which in turn connects to the off-gas tubes going into the bottles. This one in the back is the snift valve, which has a ported orifice in it and is connected to the snift tube up inside the rubber gasket. If either of these valves fail or get debris in them, you can have problems with counter pressure and proper filling. So it's a good idea to test them if you're having that kind of a problem, and it's very simple to test. In the not actuated position, both valves will flow straight through. So simply take a piece of hose, press it onto the valve, and blow through it. You should be able to blow freely through the speed valve provided the black knob is open. The same with the snift valve. Now when you actuate these valves from the control panel on the manual override screen, which is this one, and continue to blow on the valve down here, it will change positions to the block valve, and in this way you test that the speed valve shifts position and that the block valve is working. There we just proved it because I could not blow through it when the valve was actuated. Perform the same process for the snift valve and make sure that it is working properly. If both valves are working properly, the next thing to test is the adductors. To test the adductor, simply press the adductor button on the manual override screen, which is this one, and put your fingers over the hose barbs at the same time. Because I'm holding the camera, I can't do both. But both these tubes should have good vacuum on them, and it should be equal every time the adductor is activated. As I said earlier, everything on the machine can be tested from this screen. We've already tested the speed valve, the snift valve, then we can test the CO2 valve, which is the one over there on the far side of the machine, and ensure that it is blowing gas out where it should and that we have good strong flow. A shortage of CO2 will cause counter pressure fails and is a very common problem. Easy to fix. Usually it's a CO2 delivery issue that can be corrected with just minor things. Often it is nothing more than the pitcock valve on the CO2 regulator delivering pressure to the machine because there's a ball and a spring in it, and the spring gets collapsed when the CO2 is turned on and causes an inadequate flow of CO2 to pressurize the bottles in time. We can also test the pulse valve, which is the other valve connected to the off-gas tube. It's the one that can help to make bubbles, foam coming to the surface just before capping. Cap drop are the two pins that shift positions to drop one crown at a time, but they also control the rotator for the cap sorter. If you remember, the rotator is this device with the 4 air cylinders coming out and a rack and a pinion. It needs to rotate 450 degrees into the hopper for the caps, and then 450 degrees to put the caps in the chute. Speed is very important on this, and this is one of the adjustments you may have to make over time. First, I like to ensure that the rotator actually rotates 450 degrees, and you can do this with nothing more than an ink mark on the end of the cylinder. If we push and hold the actuator for the cap drop, we see that it rotates 450 degrees. We want to set the speed for this such that it does this rotation in approximately 2 seconds or a little bit less. When it rotates forward to put the caps into the chutes, we want it to go about half that fast. So as you can see, it takes 4 or 5 seconds to put the caps into the chutes. If this speed is incorrect, the machine can flip caps clear across the room, and it's also very hard on the rack and pinion. Again, 2 seconds into the hopper, about twice as long to put caps into the chutes. If the speed is incorrect and it needs to be adjusted, it is done with these 2 little small thumb screws. right here on the airlines. The blue one controls the exhaust flow for the B side, so it controls the rotation speed into the hopper. The white line controls the rotation speed into the chutes. If adjustment is needed, make a mark on the end of the shaft, just as I did. Press the cap drop. If it's too slow or too fast, make an adjustment, and then press the button again until you have the speeds that you like. Final testing can be done by going to the leak test screen, which is the only one that the bottle detection system is disabled on, and operating that, because you can ensure that the cap drop runs, that you makes full rotation, and then starts to put the caps into the chutes. Bottle indexing speed is also very critical. You can do this in a couple of ways. On the older machines that do not have bottle detection, simply push the bottle index key and observe how fast the bottles are moved forward. And then again, the plate can retract faster. The goal here is that the bottles are indexed forward and come to a complete stop about a half a second before the crowner bar starts down. On N-series machines, we have bottle detection controls. That is this screen here that we have, that we can use this bar to adjust the speed of the bottle indexing. It is very easy to use. The first time into the screen, hit reset, just as we always do. Push your bottles back without any caps in the machine so that your bottles are lined up and pushed all the way against the deck. You may need some weight here. We use a box with some weight on it just to create friction. Full bottles work even better. We always need weight so that the bottles don't skid past the location. The way this works is that when we push the bottle index speed button on the screen, the bottles move forward, and the red bar indicates the amount of time it takes for the bottles to move forward. Ideal speed is between 1.3 and 1.7 seconds. The bottle detection system is what operates this so that we know that bottles are correctly located under the fill station. Let me run that one more time. And you can see the indexing plate stays forward until we push the bottle index key again. In this way, we can measure the exact amount of time that it takes for it to index bottles forward and be detected. Again, as long as it's between 1.3 and 1.7 seconds, the speed is correct and does not require adjustment. If it does require adjustment, this is done with the thumb screw underneath the bottling machine. That's this one right here. Controls the forward motion. The forward motion is much more critical than the reverse motion because the bottles need to get there before the capper starts down. As long as we're on this screen, there is a feature for bottle detection bypass. If for any reason you ever needed to completely disarm the bottle detection system, it can be done by pressing the red button. The numeric keypad comes up and you have to put in a secret code so that it bypasses the bottle detection system. This is the auto filling screen. This is the one that you'll spend most of your time on. Starting in the upper left, of course, is the main menu key with the little wizard on it. The reset key, which always needs to be pressed before you start any cycle. So right now I haven't pushed it, it will not start. The keys below it, pulse on, pulse off. Simple as push it on, push it off. If you want double evacuation instead of just single evacuation, you press that key and leave it on. Below that, we have cycles per minute. On the right hand side, cycle time in seconds. Starting again at the top, pulse intensity. This is that CO2 valve up there that puts just a brief blast of CO2 through the off-gas tubes after the bottles are filled to create a foaming. This is only one of your controls for controlling the foaming. This bar is the actual temperature of the product. It's hanging in the air right now, so it's 70 degrees. Auto fill detect is next. Auto is the default. Auto fill detect works like this. We detect pressure change over time in the bottles. So in the auto mode, the computer reads the product line pressure, this one over on this side, during the pour, records it, and then calculates an appropriate pressure change over time after the pour starts. So you have a static pressure compared to a pouring pressure, which gives us a number. If you're in the manual mode, for some reason, if the auto mode does not detect properly, this can happen when there's excessive gas coming out of solution during the pour, you can switch it to manual, and then you adjust the fill detection number with this little bar. Each increment of the fill detector equates to 1/170th of a psi. So at 36, I've got 36 170ths of a psi that the computer is going to look for as change in the bottle over a 25 millisecond period. So what the computer does is it loads the actual bottle pressure, not displayed right now, during the pour, and for the next 25 milliseconds compares it to that number that you put into the fill sensor. If it sees that much change, bottles are full, picks up the heads, moves on. If not, reload the pressure to whatever it's changed to, and then start the process all over again. In this fashion, we can ignore shape changes of the bottle, such as a shoulder and that kind of thing that would otherwise affect the fill detection if we didn't do that. Next to that, low pressure is always adjustable. The low pressure is the actual pounds per square inch of pressure left in the bottle after the filling process is done. The fill valve is shut and tells the computer that that's the pressure we want to lift the heads out of the bottle. This allows us to adjust foaming, amongst other things, along with how fast we pour the product. This typically is something that you want to set high enough so that there's never more than 1 second elapsed time between when the fill valve, the pinch valve up on top of the machine, when that bar pinches the hoses shut, to the time the filling heads pull out of the bottle, should never be more than 1 second. That's called the 1 second rule. It's in your manual. We have 3 indicator lights up here, which are run, pause, and fail. These lights will come on depending on what part of the cycle the machine is. Remember the liquid pressure control valve here that can be connected to your bright tank to control the pressure. This is turned on simply by pushing a button, and it gives you arrow keys. Now, when you're normally operating in the auto mode, when the machine is actually operating, this pressure will instantly become whatever pressure the product is. And that way you can adjust from the known pressure. And then the machine will read that pressure every cycle and correct it in the bright tank, so your dispensing pressure is always the same. Okay, I've loaded bottles onto the machine and crowns. We're going to dry run it a little bit here in the shop just so you can see how things progress and how it works. The thing is here that I do not have a liquid source, so we've connected a hose to an air system so I can create pressure in the bottle and also pressure regarding CO2 from the same air source. And what we're going to do is put the control system into manual, because in auto it will not detect unless there's liquid flowing through the machine. And this will give us a chance to hear and see crown sorting, bottles indexing, and how it works. So with that, we'll just get it started. Always have to reset before we start. Press the go button. Bottles index forward. Counter comes down. Filling station does its pre-evacuation, brings the bottles up to pressure, and then starts to pour. And you can see that we have equal pressure liquid and bottle side. And I'm going to trick it by pressing the off gas. Heads raised. Index's bottles forward. Okay. And do it again. It's very difficult to do when you're by yourself, to show as much as possible. You'll notice that while the capping can be heard, it's when its bottles have liquid in it, this should be a thud, just a hollow kind of a thud when it puts the caps on. And this is because the crowner should come down in a continuous motion. If you have a compressed air shortage and the pressure ever drops below 80 pounds on the regulator that we talked about earlier, then the crowner will come down, pause, and then when it breaks the caps over, make a huge loud crack. When that happens, it's very hard on the machine because the bottles see a lot more pressure due to the crowner stopping and building up pressure, and then when it finally starts and does break over the crowns, it slams them into the deck. This can cause premature wear of the deck, as well as upsetting the bottles on the machine due to the heavy hammering of that situation. Let's see if we can't see that further working. Okay, and now it's putting crowns into the sheet. And that's about the speed that we want them to move. Okay, we've got crowns on. We've got one last row. Now, since this machine has got bottle detection on it, the next time we index, because there are no more bottles, it should be able to detect that bottles did not index and tell us that that is what happened. Index bottles, and you see how the indexing plate indexed back immediately, and we get a message on the screen that bottles did not advance. Each time that bottles do not advance, or there is a misfeed and that is detected by the machine, it will be in this paused condition. The thing to always remember, this is the first thing the machine does, is it drops caps so that they're available in the capper when it's ready to come down. This means that there are crowns suspended in our system that need to be retrieved before you can run another cycle. One way to do this is with the magnet on a stick that we provide with each machine. You can simply reach in and get the caps out. Need to take all of them out because if you don't, the next row that index will have two caps in there, and you'll have a major crash when the machine tries to install two crowns on the same bottle. Sometimes they're a little hard to get out, but you can get them out. The other condition that the bottle detection system is capable of finding is that the bottles did not index properly. In this case, I've removed a bottle at the filling station to achieve this fault, and the machine will tell us that there were no bottles present, meaning that there is no bottle there. So don't put the crowner head down. Again, since the machine ran, the first thing it did was drop caps. We have to fish those caps back out before we can correct the situation and restart the machine. Okay, now I'm going to take you through a basic setup procedure. The first thing to do, with no air pressure on the machine, no caps on the machine, is to line up 6 bottles the best you can underneath the capper, and we like to, if possible, push the capper down by hand so that it locates those 6 bottles. I like to do it by getting down on my knees alongside the machine and looking down the bottles across and making sure that they line up as closely as I can underneath that capping head. On most machines, the capping head will probably come down by gravity alone, but if you need to help it a little bit, that's fine too. This is just a safety precaution so that the bottles are lined up underneath the capper. Now, with the bottles in this position, loosen the thumb knobs on the rails and spread the rails completely apart. What we're going to do is we're going to run the capper and bring the bottles to their proper position and then move the rails to the proper position to locate the bottles. So at this point, what you want to do is connect your air first, because if you don't, the caps will just fall right on through. Place one cap in each one of the chutes. So we've got a cap for each bottle. Now, since the bottle ejection cylinders can only be relieved when there is a cycle running, and the only cycle that runs without bottle detection is the leak test cycle. So what we'll do is we'll go to the run leak test. We'll start the leak test. One set of crowns come in, they move the bottles to the proper location, and the leak test will fail. But the important thing here is that we have the bottles accurately located with the capper so that they are pinned in place. Now, the next thing you want to do is move those rails in on both sides so that they touch the outside bottle. That's pretty hard to see in these pictures. I have a little bit of clearance, so I'm going to adjust those rails in just a little bit. Okay, on machines prior to the N series, the rails touch the bottles. On N series and newer, we want a very slight clearance, and on this one it's going to be the bottom rail. Can't get a good picture on that side. Here we go. Just a little bit of a gap. Not much, maybe a matchbook cover or so on each side is all that you need. So what we've done, since the bottles are hard located by the crowner, and the crowner is still down with air pressure on it, these bottles cannot move. You can't budge them. That allows us to set the location of the rails. Since the bottles vary quite a bit, you may have to do this a couple of times to get the rails exactly where they need to be. The next step is going to be repeat the cycle, only this time with bottles under the fill station. So what we do is we turn off the leak test, we reset it, we go back to the manual override mode, and we come over and we're going to place one more row of bottles just in front of the ones we just capped. Remember, there are no more caps in the cap slides, but we do have cap bottles located under the capping station. When we locate bottles under the filling station for this setup, we press them in so they just touch the ones under the cap or just a tiny little bit, and maybe even move them back just ever so much. Okay, and the next step is going to be repeat that leak test cycle. Run leak test, start the leak test, comes down, and what, we almost lost the bottle there, but it is located. So now we have the locator down with capped bottles there. So the bottles are located front to back. I want to make sure that they're all in there and sitting straight up and down like they should. And what we're going to do is we're going to come around, we're going to disconnect the air without resetting the machine. And what this does is it allows us to set the indexing plate. So I'll remove the pusher bar, and I'm going to place one more row of bottles in front of these. Okay, one more row of bottles has been set in front of the filling station ones we just did. And the reason for doing this with the air taken off is we can now loosen up these bolts that go all the way through. Our indexing plate mount has got slotted holes here, as well as multiple indexing holes through the frame. The way we set this is loosen up those bolts on both sides, grab a hold of the air cylinder here, pull it all the way back, and then reach all the way underneath. I don't think you can see it, and push the indexing plate all the way forward. Grab a hold of the sides of the plate, move it forward until it just touches that row of bottles. Make sure that the plate is fully extended in the air cylinder so that this will be its stopping point once adjusted. This plate should come out and just touch these bottles. Don't be surprised if there may be one in the pile that doesn't quite exactly touch. Bottles vary that much. But you want to make sure that it's definitely straight side to side, so when it indexes the bottles, they'll be in the right place. Once you have this set, come back to your adjustments on both sides and tighten it down good and snug so that it doesn't move. Now you've adjusted the rails based on the capper, and we've also, which gives us our side to side, and we've also adjusted our front to back with the indexing plate. Now, before resetting the machine, always remember to put the compressed air back on the machine first, because if you don't, what can happen is the air pressure changing as the cap heads come up, the ejection cylinders lift the bottles and then shoot them out, and you have a glass bullet coming out. So now what I'm going to do is turn off the leak test, reset it, which brings the heads up, and that completes our setting of the rails side to side and our indexing motion front to back. The last thing I want to cover today is how machines are packaged for shipment. When we ship a machine, these airlines are removed. They are labeled, one with a B or an A, for which port it connects to. There will also be a label on the cylinder fitting itself. The two bolts here that mount it to the frame are taken out, and the fill valve and manifold together are flipped upside down and put into this area for shipment. There'll be a note on it that will tell you and show a picture of how it's supposed to be mounted. Also, the control panels are removed from the machine. All the hoses are push in the collar and remove the hose. So it will come with all the hoses disconnected. Again, they're labeled with each number corresponding to the computer output, and also an A and B for the front and the back. The sensor lines here will be disconnected, and also the bottle detection lines. Again, everything will be numbered. The control panel will be in its own box. So when the machine comes to you, you'll have to mount the control panel, and the bolts will be here for the rubber bumpers which go flat against the frame. Mount the box, plug in all the hoses where they belong, flip the fill valve over, plug in its air hoses, and it should be ready to go from there. We set up all the machines and test them here in our factory before they are ever shipped. This is the crate that your bottling machine will arrive in. It's a fluted plastic material that makes up a box. The machines are strapped down to a pallet in the bottom, and it's mounted on skids. When this gets to you, remove the screws from the pallet and the box, remove your machine, take your parts out, you'll have to mount your bottle rinser rack, and also the control panel and fill valve that we talked about previously. I hope this video helps you in your learning to understand how the machines work and what needs to be done to set up and maintain them.